Welcome back to Morgan Dynamic Research. So far in this series we have built up a picture of the three-force fractal model substrate, thought and void, the three primal forces, the tapestry of nodes, tick and scalar time, the stack at each node, and the temporal costs TD and TCD that define mass. In this video we're going to talk about how influence spreads in that world. We will introduce locality, the idea of a discrete light cone, and a high-level view of barrier bands.
In 3FFM, all change is local. That is a strict rule, not just a guideline. At each tick, a node is only allowed to update its state based on the information in a closed neighborhood around it. It cannot look across the entire tapestry to decide what to do. It can only see nearby dihapple, nearby source flow, its local stack, and present configuration.
This means that information and influence can only move through the tapestry step by step. In one tick, a pattern can affect its immediate neighbors. In 2 ticks, it can affect neighbors of neighbors. After 3 ticks, it reaches 3 steps away, and so on. There is no way for a change at one node to instantaneously flip a distant node in a single update.
If you draw the set of nodes that could possibly be affected by an event after 1 tick, 2 ticks, 3 ticks, and so on, you get a growing region that looks like a cone. When you plot distance versus time in continuous space-time, as in standard relativity, this would be called a light cone. In 3FFM, this is a discrete light cone built out of nodes and step counts, but the idea is similar. There is a hard limit on how fast influence can spread through the substrate.
The cost structure adds another layer to this. Every relocation of a tagged dihapple has to pay at least a minimum relocation cost in ticks, and often more if alignment and configuration have to change. This gives you not just a geometric bound from locality, but also a cost bound. To get a pattern a certain distance through the tapestry, you have to spend at least a certain amount of temporal cost.
In the math framework paper, we formalized this as a path length versus temporal cost inequality. The idea is simple at a high level. The farther a tag DH worldline travels in a given region, the more TD plus TCD must have been spent to support that motion. This leads to an average velocity bound for that worldline in terms of the average cost rate. There is no way to cheat the ledger and get arbitrarily faster motion for free. In this way, 3FFM shows that every motion of every system carries a temporal price, and mass is the temporal resistance recorded in that ledger.
Now we can say something about barrier bands. A barrier band is a region of the tapestry where, for a given tagged dihapple and time window, the temporal costs vanish in a specific sense. If TD and TCD both remain 0 there for that DH, then no motion or reconfiguration involving that DH actually takes place in those nodes during that period. For that world line and that interval, they are effectively frozen.
The math framework shows that as long as those cost conditions hold, the tag DH cannot have crossed that region. In that sense, the band is impermeable for that motion. But this is not a metaphysical wall. If a DH ever does relocate through those nodes, the cost stops being 0, the ledger records that passage, and by definition the region is no longer a barrier band for that world line. A barrier band is a statement about what the ledger says has happened in a region, not a permanent prohibition on what could ever happen. In other words, barrier bands do not stop the tapestry. They tell you where, for a given DH and time frame, the tapestry has not done any temporal work.
So locality, the discrete light cone, and barrier bands all come from the same ingredients: strictly local update rules, discrete tick-based time, and a non-zero temporal cost for motion and configuration change. These features are not put in by hand at the level of particles and fields, They are consequences of the substrate itself.
To summarize this video, locality means each node only updates from nearby information. The discrete light cone is the growing region of nodes that can be influenced over ticks, defining a hard speed limit for influence. Barrier bands are regions in stasis where no temporal cost has been paid, so they act as dynamic partitions of the tapestry for that system.
If you want the equations and proofs for these structures, that is what the math framework of a deterministic substrate is for. From here, the real story is what the substrate can build. In future work, we will use it to generate heat and light, and then the higher order structures that lead toward the familiar forces and particles of modern physics. Thank you for watching this 3-force fractal model Series 1 review. And as always, I encourage you to continue to seek truth and never let your light dim.